This is the first Clever Friday on a Wednesday. Hopefully it's a little bit more convenient for everybody here. I see we're almost at 50 people already here. So thanks for taking time out of your day in order to learn something new. Today I'm here with Michael in person, and I'm going to let him introduce his good friend that he's gotten to share some of his time to teach us and to share some of the latest and greatest technologies that we may have an opportunity to use here, and take any questions from some of our developers that have been in production environments, and probably have some good, interesting questions for you as we go through this. So Michael, take it away.
Cool. I'll be brief. This is moderately fun for me, only because it is very rare that our Clever Friday, Clever Wednesday, Clever Chat is actually like a buddy of mine in real life versus a stranger on the internet. Super excited for you guys to hear a little bit about what Mike's team's been building, and you know, I'll turn it over to him. I know he's got some exciting stuff to talk to us about, both on their main project as well as some new things they're doing. And I wholly encourage us to toss out a bunch of questions as we go through, if that's good with you, Mike. Cool. Other than that, just mute when you're not talking, and we should be ready to rock and roll. Mike, it's all yours. Yeah, Mike, your mic might be off.
Okay, how are we doing now? All right, we're good. All right, guys. Thanks a lot for the introduction, Michael. I really appreciate it. My name is Mike. I'm one of the founders of RethinkDB. RethinkDB is an open source database. It's one of the largest projects on GitHub right now. It's an open source distributed database. And it's a company that we've been working on with our team in the Bay Area, in Mountain View, California, for the past 7 years. So I have a talk that I'm going to walk you guys through to show you a bit about what RethinkDB is, why so many people are adopting it for a class of applications called real-time apps. A really exciting new type of application. And I'm going to talk about some new projects we have and what it's like to build an open source company and to work on an open source project, and to really grow that community. I encourage you guys to use the group chat to let me know if you have any questions and things like that. You will have an opportunity in the demo app I'll be showing later to just submit questions about Rethink and upvote them. So you can, if you have any questions you have at any point, don't hesitate. Just I'll check periodically for whatever questions you guys have. I want to make sure I get all the details addressed. In the meantime, I'm going to share my screen here, so give me just a moment so we can get started with the talk. All right. Can everyone see this? If someone can just let me know in the chat, I would appreciate it. All right, thank you. All right, so as I mentioned, RethinkDB is an open source database that's designed for the real-time web. We started RethinkDB, we started working on it about 7 years ago, coming out of Stony Brook University. At this point, it is a very large, popular database and used by a lot of developers. So over 130,000 developers are building with RethinkDB today. And they're people at teams, you know, in large, like one of the largest online brokerages in the world with over 25 million customers, runs a 25 node cluster of Rethink for their primary user accounts. NASA, I just found out last week, I'm like super excited about this because I found out that NASA is using RethinkDB to track data on EVAs when astronauts leave the space station, to be able to figure out the spacesuits and all their equipment's in good working order, and to do real-time analysis on what's happening with the data set. And so, you know, RethinkDB, as I mentioned, it's an open source project. It's built by a core team in Mountain View and also 100+ developers around the world. We'll all collaborate and build it together. We all do all of our work out in the open on GitHub. If you're curious about how we work, you can just follow us on GitHub. There are hundreds, thousands of people who check in with us to find out like what's going on with every single issue. You can get involved in the discussion, and we do everything out in the open. We have an open development process that makes us feel like an open source project that really has a lot of funding, focus, and is able to scale and build something that's used by some of the largest organizations in the world. So I want to talk a bit about what I mean when I say that RethinkDB is an open source database for the real-time web. So RethinkDB is, just briefly, it's a distributed database. You can scale it to many nodes. You can scale it to large clusters, and it scales linearly as you grow. It also offers something called real-time push, which allows you to subscribe to data and streaming data updates from your database. So first, before we dive into what this all means, I have to first describe what I mean by the real-time web. So I think everyone's probably familiar with their first experience with Google Docs. You open up like Google Docs and you see like a blinking cursor, and you're like, oh, it's a text editor. And then you see people start to type, and you're like, this is not just a text editor, something very unusual is happening here. It was a very visceral experience for a lot of people when they first touched Google Docs. And it's because for the first time you get the sense that there are other people that are like interacting with you, and you're getting real-time updates from other people around the world. And so that is a pretty that's a pretty profound realization, and it changes how people's expectations, the kind of apps that they work with. Another example of this is Slack. Sorry, I think my computer's lagging a little bit here. There we go. Okay, so Slack. So Slack is a good example of a modern real-time app. It exhibits a lot of the properties that these kinds of apps have. So for one thing, it doesn't matter where you are, you're always able to get updates on what's happening across different channels, across different users. You get push notifications on your phone. And also, it doesn't matter if you're using your desktop or using your phone, you kind of move from one environment to another, and the stream of information follows you. It's also like cross-device. You know, it has a lot of properties of modern apps that are responsive and friendly that we expect. And the fundamental problem is that while these kinds of apps are really compelling, where you're interacting with other connected clients, where you're sharing and exchanging information, fundamentally building real-time apps is really, really hard. This is why so few teams have built large, scalable real-time apps. The biggest issue, and I want to talk a bit and focus on why it's hard to build these kinds of apps, because if you guys are thinking about building any of this class of applications, collaborative web and mobile apps, streaming analytics, web and mobile, IoT for Internet of Things, gaming environments where you have lots of connected clients sharing information, anything where people are pushing state to each other. The biggest problem is that it's hard to keep track of state when you're building a real-time architecture. So if you want to build something like Slack, or you want to build something like Google Docs, figuring out what's changing and how to keep track of it is the biggest problem, and it's your enemy. So let's look at a typical architecture diagram. I hate architecture diagrams, so bear with me. But in this case, they're actually quite instructive in helping understand what's going on. So in this example, we have like two real-time web app servers, right? We have like some, like for example, Slack on the web, right? And they're like logged in via Slack on the web, and you're able to see the app. And when you log in on your phone on the mobile app server, it's coming from a different server, but you're still getting the same updates. Typically, you'll have a database that stores all your data, and then to push updates around between each other, you use something like a message queue. Things like RabbitMQ or Kafka are systems you need to be familiar with. The problem with this is that at this point, you see a lot of arrows and a lot of boxes moving around. It's because all of these pieces have a little bit of information about what has been updated within the state of reality, the state of truth. When someone writes a new message on Slack, you have to figure out who to push it to, how to push it to them, and it's incredibly difficult to do that. So the way that people typically do it is that they'll pull the database. They'll repeatedly write some query that represents like, what are the new messages? And then they'll pull the database and they'll repeatedly ask the question, what's changed, and try to compare it and diff it. The problem with that is that pulling data to keep track of these kind of updates, it's really cumbersome because you have a lot of moving pieces and you don't know what should be talking to whom and where. Because it's so hard to be able to just build basic functionality like chat, adding new real-time functionality it just keeps getting harder. So teams choose not to build new features because it's incredibly challenging to start to build these kinds of apps. And this is a more subtle point, but if you think about the example of like a chat system, you have like a bunch of messages that are floating around, but you don't necessarily want everyone to receive them. You have to figure out who gets what and where. How do you route these messages? Do I just send them to everybody and ignore the ones I don't care about? Or do I figure out how to like tell who cares about what and try to communicate that state throughout the system? So fundamentally, it's hard. And so teams don't want to build these kinds of apps typically, or they have to push themselves to figure out how to do it. Unless you have the engineering resources of someone like Facebook or Google, or if you have an engineering team like the quality of Quora, it's going to be very difficult to build these kinds of things. In fact, the Quora CTO very famously gave a really good talk on how to build these kinds of real-time architectures. And it's a great talk that you can find on YouTube if you're curious about how they did it before any of the open source technology that exists in the world today existed. So that brings us to RethinkDB, because RethinkDB is set out to solve this problem. So what is RethinkDB? RethinkDB is an open source database for building real-time web apps. It's really good at solving this class of problems. In general, it's a very good general purpose alternative database. If you're using things like, if you're familiar with things like MongoDB, it's a NoSQL database that stores JSON documents. And you can run all the code in something like Mongo and even more because the architecture is a little bit more sophisticated. But the similarities stop after that. It looks a lot like Mongo when you start using it, and it's a very good general purpose database. But a lot of the features that make it unique and differentiated and exciting center on the fact that both it's easy to scale linearly, so you can easily just throw nodes at the system and it'll grow in a linear fashion. There's a team that recently demonstrated scaling Rethink to 30 nodes on Amazon to accomplish 1 million ops per second. And that was on normal like AWS instances. They published a public white paper about this that if you guys are curious, I can link you to. And the point is that it's really easy to scale it. But more importantly, it has real-time push. So RethinkDB is designed with this real-time push. Basically, it's built for building these kinds of real-time apps. And what does that actually mean? So here's what RethinkDB does that's unusual, different, and interesting from every other database out there. It lets you subscribe to change notifications on database queries. And what that means is that if you have let's say in this example here, we have a simple query for RethinkDB. We're subscribing to a change on the users table, right? So our.table users is how we access our table. And then we say .changes and we open a stream. And now what's gonna happen is that every time that a document is modified, added, or removed, you get sent a little push notification that notifies you something's changed. And by subscribing to these notifications, you're able to keep up to date on what's happening. Now, this is really important because it means that you don't have to pull any longer. The database pushes change events with a live stream of updates. And you can consume just the updates, the diffs, piece by piece, that allow you to figure out what's changing. This is the fundamental utility that RethinkDB exposes that we then build upon to be able to make it incredibly simple to build these kinds of apps. Change feeds let you build scalable real-time apps. And that's because if we look at our example again one more time, here's what we have. We have the same app servers and our mobile server. Now, notice that they're not talking to each other whatsoever. Each server is putting this data directly into Rethink. And then each server is also subscribing to a change feed to get a sense of what's coming back from the database, what is new that's being inserted by everybody else. Because you have these feeds, these streams, they're stateless, completely stateless. They don't know about each other. They don't care about each other. You can open 1,000 of them, 10,000 of them, or 2 of them, and it wouldn't make a difference. And they scale really easily. You can just open a change feed. So change feed, just in terms of how expensive they are, they're as cheap as a connection. You can open thousands, tens of thousands of these streams. We've pushed it to 10,000 plus streams, and we haven't hit the upper bound yet because we're testing network scalability next with the database. But ultimately, you can open tens of thousands of these streams per server, and then you can add servers as you scale the actual cluster. So these change feeds are incredibly scalable, and there are production apps that entirely function on change feeds. It changes how you actually build the software because it just makes for simpler architectures. And it helps you build these scalable real-time apps. So as I mentioned, the kind of things it's really good for: collaborative web and mobile apps. Things where people are exchanging information like Google Docs or Dropbox, or Google Analytics. Or Google Docs. Multiplayer games because people are exchanging information in real time. Streaming analytics apps where people are trying to figure out what has happened within their transaction system, but they don't want to wait like 12 hours to dump it to an analytics system for deep analysis. You build a lot of streaming analytics for specific interests with something like Rethink. Real-time marketplaces like ad exchanges, and connected devices, which is my favorite because the Internet of Things had the promise of having lots of devices that exist in the world that would be always pushing new bits of data and help you understand what's actually happening in the physical world. And so you can imagine an example, and there are companies that are working on problems like this that have been working with Rethink, where you can have a farmer in a field where they have an iPad and they define like the bounds of their property, and they have sensors that are sitting throughout their farm, and all these sensors are generating data about like humidity and moisture and the weather and sun exposure and things like that. And you can imagine having, like, if you want to do variable fertilization, where you want to figure out when's the ideal time to fertilize the crops based upon all sorts of metrics, you can have streaming updates across all these thousands of devices deployed and be able to reactively listen for when a change happens and it's time to go and fertilize that field. And the whole point of this is that there's a class of data which is very valuable. And that data has an expiration date that expires very quickly. If you act on it in the moment, you can drive enormous value. You can build really amazing things. But you need tools to be able to let you react to how the data is changing. So before we dive into how these change feeds work, it's important to take a short detour to talk about what it's like to query RethinkDB, because that actually is worth paying attention to for a minute. So here's a basic example of a query in REQL. So REQL is our query language. If you're familiar with SQL, this is our variant. It is unlike other query languages for databases, for NoSQL databases, in that it's designed as a complete programming language. It embeds into your native language. So if you're running Python, Ruby, JavaScript, it'll just look and act like native code. This is an example in JavaScript. So in this case, we're doing R, which is the namespace for the module, .table users, then .pluck to get the property last name, then .distinct to get the unique set from the set of last names, and then .count to count the actual number of names. Now this looks like pretty simple code, right? We're accessing the table, we're isolating a single property, we're consolidating all the values, and then we're counting the number of items. And so this looks and feels like native code because it is. It embeds natively into your programming language. In SQL, you send over a string that represents the SQL query you want to run. In something like MongoDB, you would send over a data structure that represents, using some native operators, that represent the transformation you would want to make to your data. With RethinkDB, it looks and feels like you're just dealing with data, with native data structures that just live within your environment. And that's because we did a little bit of magic. So it embeds natively into your programming language, but it's actually executed on the server in an efficient distributed fashion. You compose queries, data flows left to right, so you chain things out. If you're familiar with things like jQuery or other chaining APIs, this will feel very comfortable. Fundamentally, for those of you who are programming language geeks, it is a functional composable programming language that embeds into whatever language you're using. And there are Python, Ruby, JavaScript, and Java are the 4 official drivers with support and documentation, but there are over 20 plus other languages that are very actively maintained by very large communities. Some of the largest projects include Go, Erlang, and .NET. And so REQL is very powerful. You can do, it gives you branching logic. You can do grouping. You can do MapReduce. You can do joins, distributed joins. So you actually have efficient distributed joins in the system, unlike other document stores. And you get a lot of very subtle, detailed logic that you can build with REQL, very elegant expressions. Now, this is the reason why it's important to mention what it's like to query Rethink is because I mentioned that these streams work on queries. And this is the really fundamental bit. Because this is an example of a query where we're telling in our new social network when a user profile gets over 30 likes, meaning when we think it's popular, because we have a small social network, no one's on it yet, right? So we take our user profiles table, we're filtering, and here we're giving an expression where we're saying, for each row, look up the likes property, and for everyone who has likes greater than 30, match and then filter it. So this is a query. We could run it and it would tell us who has user profiles with over 30 likes, right? But let's say we wanted to figure out what's changing and find out every single time that new user profiles enter that category. So we just attach .changes to the end. And .changes now opens a stream, and clients can subscribe to this stream of real-time updates. So I want to play with change feeds for just a second so you guys can see what I'm talking about. I'm going to stop the presentation. I'm going to go to a demo that I have, and I ask you guys to join me. If you can all just join and type in questions.rethinkdb.com. It's a demo, so please forgive me if we encounter bugs along the way. But go ahead, and I'm going to go ahead and open up my, I'm going to go ahead and share my browser here. My whole desktop. Okay, perfect. Can you guys all see this? You can just shout out in the chat. I'd appreciate it. All right. Okay, so this is questions.rethinkdb.com. So this is basically a real-time, there we go. All right. We already have some people who are submitting questions. So what I want you to do is I want you to ask questions about Rethink, but also while I'm doing this, I will address these questions later. So take your time and ask if questions come up about Rethink, about a new RethinkDB project I'll talk about later called Horizon. If you have questions about that, go ahead and enter it as well. And if you have questions about just building an open source company or how to grow an open source community, anything that you're curious about, go ahead and put the questions in. In the meantime, while you can see people are basically, it's a real-time app, people are upvoting, we can go to our database. So this is basically RethinkDB's UI. We built RethinkDB with a dashboard so that it would be easy to play with so you can figure out what's going on. You have this available at every node when you work with Rethink. You can see that writes and reads are already happening within our database. So this is you guys who are upvoting and asking questions, which is really great. So I want to just jump quickly to the Data Explorer. The Data Explorer is a tool that we provide that basically gives you a way to write queries and see responses and open change feeds. So what I want to do is, first of all, you guys can tell that it's all updating on all of our systems. How is it actually doing that? So we're going to write a little query here just to show what's going on. This is r.db. So I write my database that I want to pull it from. You can see I have tab completion, syntax highlighting, all the niceties. Table. Okay, so I'm going to say questions. Okay, so if I just run this query, you can see that I get like a list of questions. You guys are asking some good questions here so far. If I wanted to see what's going on, we can just say .changes. So in this case, what you can see is happening is we're listening for events. Now, if someone would just upvote a question or submit a new question, that would help me out a little bit. Let's see what comes in. There we go. All right. So here, what's happening is we're seeing a live stream of updates coming in from that table. Now, I'm going to pause the feed so we actually can look at it because it's changing too quickly. It's worth examining what the output is for a second because it's quite interesting. If you look here, we have two properties, new val and old val. Old val represents what happened previously, what the previous state of the document that's changing is. And the new val represents the new properties. So in this case, we can see that the points were 38 and now they are 39. Now, if old val is null, that means that we have a new question. If new val is null, it means that someone deleted the document. And so what you can see by comparing the output, you can figure out exactly what's changing and implement the semantics in your app to be able to like actually build the full real-time app. Now, the architecture, just briefly, front end is in something called Vue.js, which is a very simple front end framework similar to like React or Angular, but a lot more minimal. The back end is Node.js with Socket.io, and I'm using Socket.io to pull up all the change events and pass them up to the front end. So pretty straightforward, pretty easy to work with. All right, so basically, one more thing I want to show you. So let's go ahead and let's look at, so I have another demo app that's running here. And this is running, if you guys can see this is a dashboard. And while you guys have been asking these questions and while you're upvoting them, it too has been updating in real time. So you can see that it's changing. And the magical thing about this is that these two apps know absolutely nothing about each other. So on the left, it's talking to Rethink and it's subscribing to change events to figure out what the current vote count is on the left. On the right, it's subscribing and saying, just tell me all the questions grouped by the vote count, and then just tell me exactly how many of them there are so I can plot them for you. And so what's nice about this is that these two apps will continue to just interact, and the only thing that's connecting them is RethinkDB. That's it. So the architecture is very straightforward and simple. This is how you can build really scalable real-time apps, where you can have front-end transaction apps that are running real-time events, and you can have analytics that are running in parallel on the same system, on the same data set, working with the same application. Now, I mentioned that this works on queries as well, so I want to just briefly show you what that looks like. Let's take a sample query. So I'm just going to pull up my history here because I have a couple of queries that are useful and fun. So I'm going to do this. I'm going to order my queries by the number of points. I'm going to order the questions by the vote count. So you can see what I'm doing here is I'm saying order by using an index I've pre-created where I say on the points property, do it in descending order. So in this case, you can see we have points in descending order. Okay, so what is happening is, let's say we want to just see, only tell me when things have changed with the top 3 questions. So I'm going to say .limit3. This will give me the top 3 questions. Okay, there we go. And now to just find out what's changing with those, I just say .changes. Okay, so now what we have is we have a change stream that will only return updates when anyone upvotes or changes the value on only the top 3 applications, only the top 3 questions, excuse me. So the top 3 questions are right here, and you can see that we're only seeing updates that are coming in for these 3 questions. This is really powerful because this is the thing that is really exciting about RethinkDB is that you don't just open events and streams on your data. You open it on the meaning of your data. You're able to understand what goes into, you're able to formulate something you care about and then follow a real-time stream of updates as they change on only what you care about. And only you can modify and manipulate it. You can do reductions and mappings along the way to figure out what you actually need the client to consume. Okay, so this is I think pretty short. I'm trying to go quickly because we have a lot of ground to cover. I know I speak fairly quickly. So if you guys have questions, let's drop them in the questions app. I'm going to go ahead and talk about all of these other details. Okay, so in the meantime, I'm going to jump back to my presentation here. All right, so let's look very briefly. You can check out the code, by the way, if you're curious. The URL is at the bottom there, and I'm happy to link to it later in the chat if you guys are curious. Okay, so very briefly, this is what it looks like. We had our 2 question servers, which are basically the things that you guys are asking questions in from. And then we have the actual server that runs the dashboard, which is the thing that you guys saw. Again, these apps know nothing about each other, but they're communicating using only RethinkDB. Changes are pushed directly to each stateless app server. So let's sort of review what we have so far. What exactly is interesting and compelling about all of this? So polling for data, as I said, is cumbersome. It's slow. It's hard to maintain. You don't want to do it. Polling is the enemy. The push access model, that is where you have push that starts from the database. And if you guys are familiar with the ideas of like unidirectional data flow that are espoused by things like React or Angular, where data flows from bottom to top, and because you know where it starts and where it ends, or at least where it's going, you're able to define and understand what goes on, the interactions that are happening. So the push access model, the fact that you have real-time push, it simplifies real-time architectures dramatically. One source of truth makes it simple and easy to manage state. If you guys are familiar with things like Redux in the React world, this is an example of the same idea being espoused in a different community, where one source of truth where you can define what actually is happening makes it a lot easier to figure out what's going on. When you do it at the database level, when you have the source of truth be where your data lives, this means that you can make many more powerful assumptions and you can build much more dramatically complicated architectures using fewer pieces of technology. RethinkDB is the first database for the real-time web. So it is a fundamentally massively parallelized, massively asynchronous database that, because of its architecture, is able to open tens of thousands of these streams. When we announced change feeds, other database vendors rushed to figure out how they could implement something like it. And you may see a couple other vendors out there who have ideas like live queries or listen, notify, and Postgres and things like that. And the reality is that this is very different from being able to open streams on the meaning of your data. And until other databases emerge with highly asynchronous architectures, which I believe they will, I think we're going to see a lot more databases in the coming years accomplish this. But it's going to take a change in architecture to be able to actually solve it. We also have a great community on Slack. If you guys use Slack, we have a very active, I think it's like 1,000+ people already there, and they're very friendly. I'm very happy to say that we have an incredibly positive community with really wonderful people. You can see this little guy here, by the way. I didn't mention who he is, but he's a little mascot. He's the thinker, and he's on this painting behind me that someone noticed in the chat, which is actually him with the Docker whale. We have a full-time artist illustrator who all she does is create art around the project, because we found that art is an amazing vehicle for ideas in the same way that software is a vehicle for ideas. And art can catalyze an open source community. So this is our thinker, and you'll see him pop up throughout the presentation, as I'm sure you saw, and around the documentation. But him and lots of other friendly people in the community are they're all on Slack. So you can join us on slack.rethinkdb.com. I'm going to pause for just a moment to sort of see where everyone's at. And then I want to talk briefly about a new exciting project we have at Rethink that I think you guys will be interested in hearing about. But let me just see to make sure that we're good. I'm going to check out the questions. Great. This is all. You guys are asking excellent questions. Excellent. Okay. Perfect. Okay. So I'm going to go ahead and talk about a new project that we have at Rethink. So RethinkDB is growing incredibly well. The user base is doubling every quarter. It's the fastest growing database over the past few quarters across the board. It has a massive user base. It's one of the largest projects on GitHub, approaching 13,000 stars on GitHub. And it's definitely one of the largest, it's one of the top 10 C++ projects for sure. And it has a lot of really active users, and we've learned a lot about people at teams, like NASA, or like NextGXDX, which is a genetic testing firm in Nashville that maintains real-time updates on available genetic tests from different providers and has to push them to their clients. So we've helped a lot of teams scale and build these kinds of real-time architecture. What's hard about doing it? So beyond the obvious parts of you're building the database and there's a lot of other components you have to think of. So right now I've only talked about the database, but fundamentally, by the way, here's just a few resources on Rethink while I'm talking about this. Fundamentally, when you're building a real-time app, what you have to do is you have to build, like I described, you have to build the database, right? Then you have to write a backend in Node.js, which will allow you to take data from the backend, from the database, and figure out how to do access control, how to figure out how to authenticate users, things like that. And then on your front end, you would usually use something like React or Angular or some other front end framework that is capable of doing lots of components, parallelized views, everything's updating in parallel. But there's a lot of moving pieces along the way, and it's hard to figure out how to build this kind of stuff. So our goal, our mission at Rethink, is to make building real-time apps dramatically easier. Easier than building normal applications, because we believe that all apps will become real-time. So with that in mind, we have a new project that is in developer preview right now called Horizon. And Horizon is a tool that's built for the JavaScript community. It's built on RethinkDB. It uses two properties from RethinkDB. RethinkDB's linear scale and a real-time push to be able to provide what I would call a real-time open source backend that makes building JavaScript apps dramatically simpler. So what you get is you get a Node.js server that sits on top of Rethink, uses Rethink's engine and heavy lifting to do all the work. And it gives you a simple API you can consume in the browser. And it gives you an API for dealing with streams that you can get from the backend on a variety of properties and different ways to slice and dice your data, because it's using RethinkDB under the hood. And it also gives you convenient APIs for building real-time apps. So Horizon, it solves common problems that people have in building real-time apps. It provides APIs for things like subscriptions, persistence, authentication, who is the user, can you log in with Facebook or Google, access control, defining roles and what data to have access to, session management, which is always a headache for people building these kinds of apps, presence, have two users enter the same chat room, a geolocation, where is the user physically located. And so our goal is to provide basically same defaults for 80 to 90% of apps that will be able to use these simple APIs that will solve most common problems. And because the whole stack is written in Node.js, when you're ready to write back-end code in something like Node, you can use the entire Horizon stack and you can hook it into something like Hoppy, Koa, or Express, or any other server that you're using. And you can take the entire stack and just hook it into the middleware and it'll just keep running. Which means that you push out the point at which you have to start writing a backend significantly further, because Horizon does all the heavy lifting. And then when you're ready to extend it, write your own authentication layer, write your own custom backend code that has some secret or needs to communicate with some other services. You can then use it within your Node environment and it will just continue operating the same way you expect. So the use case as an example is you can start writing a React or Angular app with absolutely no backend code whatsoever by relying on this just open source backend, type Horizon, and it's up, and you start connecting to it from your browser. And then you take the entire Horizon stack, extend it with node modules on the backend, and then because it uses RethinkDB under the hood, it scales linearly with RethinkDB. So you can start from your laptop prototyping an app. You can prototype your web and mobile app very quickly, and then you can scale it to millions of users using RethinkDB scale and using Horizon's convenient APIs to be able to actually build these real-time apps much more quickly than was possible before. And so Horizon is a new project we're very excited about. You can get in on the developer preview if you want by going to horizon.io. We're going to be running invites over the next couple of weeks. I'm very excited about this because it's not just about making it easier for people to work with RethinkDB. It fundamentally makes it easier to build JavaScript apps. And so we've been building this with the JavaScript community hand in hand over the course of the past couple months. And it's been really exciting because people are seeing an opportunity to get away from having to deal with which stack do I pick, the mean stack or the 3 stack or whatever million stacks you find on GitHub. And a way to not be tied to something like Firebase or Parse or other services where your data is hosted on some cloud service and you use their simple APIs. This is the best of all worlds. We're able to build JavaScript apps effectively and still make convenient use of simple and convenient APIs to build things quickly. So Horizon is something we're really excited about. I'm happy to chat more about it if you guys have any questions in the chat, or we can always talk offline later. At this point, I'm going to pause because I've been talking for a long time. And I'm going to go ahead and jump to the questions app and sort of see what's come up. Does that sound good? All right. Give me just a moment, guys. Okay. Looks like someone figured out how to get around my rate limiting code for the for the demo because someone's upvoting the heck out of one of those questions. Okay. So I'm going to go ahead and start from the bottom because I think that's a good way to go. Is it possible to query by value? Absolutely. So you don't always have to. If you say query by value, if you mean does a document have this value somewhere in the database? Then absolutely. There are a lot of convenient filtering and document properties. We can try to model some of those if you're curious. If you're talking about not using the streams, then yes, you can just query normally and get a response back from the system. Okay, so I want to use Horizon for a project starting Monday. How can I? I can hook you up is probably the best answer to that question. Go to horizon.io and fill out fill out the form. And then if you can like ping me on Slack, I'm available on the RethinkDB Slack. I'm just the bald guy, I'm Glukov, pretty easy to find. I will warn you that we just added authentication, and we're still working out access control. So if the thing is being built very quickly, it will ship by April, is the plan, late April, early May. You can get started with it and use it while we're building it, but just recognize that you're gonna have to deal with a little bit of a pain point because it's still in developer preview. But you absolutely can get started on Monday if it's something you wanna use. Okay, so I thought CouchDB had a changes API too. That's an excellent point, and actually is a really savvy point to have tried to build something like this in the past where you are pushing change events from your database, right? The thing is, if you look at CouchDB's changes API, it's built around the idea of syncing data, which is very, very different from what RethinkDB does, which is pushing out streams on queries. So CouchDB was building for a world. I had a really good conversation with some of the founders of Couch a few years back, where they were telling me how they were basically, their vision of the world was that, not everyone in the world had like access to being always connected. So you have like a clinic in Africa that like, wants to help their patients and they only get internet periodically because it like, goes out. And so CouchDB was designed so that you can sync the data between local and remote sources to make sure that you can you can figure out how to get the data where it needs to be when the network goes down. So it's designed for a world where like a network was spotty. RethinkDB is designed for a world where we have lots of tens of thousands of streaming updates that are always coming at you from all directions. So in Couch, you can sync a collection. And Rethink, you can do that too. But more importantly, you can take a query and then open a stream on that query, the meaning of the data. So it's very different in how it looks and feels. Has anyone built something like this in conjunction with Amazon Lambda yet? That is a really great question. And that's an example of the kind of programming that people are going to start to do with systems like this. So Amazon Lambda, for those of you who are not familiar with what it is, Amazon Lambda is a really neat, tool where for Amazon, where you can basically run a function in the cloud. So you can run a function in like Python or something like that, and you can say, now I want to run it in 10,000 servers, and that's it. I don't want to provision anything. I just want you to run it for me. And it's really awesome because if you think about reacting to your data, you can have like a query that you react to, like an event. And you can basically spin off like a function reactively on AWS to fire off only when the change happens, which means that your whole system can scale with your load, and you will pay only as much as you need for your processing power. An example of a team that used this is actually a really cool use case. So if you guys are familiar with body cams are increasingly being deployed in police stations around the world, and definitely in the US, because there are cameras that police officers wear that are always streaming, always pulling in updates. They record it on an offline server. And they're really popular because they reduce crime, frankly, or they reduce incidents of like police brutality, and they also make it easier for police officers to defend themselves when someone wrongly accuses them of unfortunate circumstances. And so it's the sort of thing where getting it on camera is very important. But in order to be able to actually release the data, they need to scrub all the images first, right? They need to remove faces, identifying details, license plates. And so when people issue a Freedom of Information Act, it takes like weeks to fulfill them. So this guy who was harassing the Seattle Police Department with these requests, he told them, look, I could just write you software that will do it more efficiently. So they hired him to build the system for them, so that RethinkDB manages all of the components RethinkDB manages all the data that's coming in from these images. And then it fires off this image scrubbing bit on Amazon Lambda. And so he built a massive architecture with very few pieces of software. Was able to do it in a really amazing way. And so because of that, the Seattle Police Department was able to shorten the time during which they were able to scrub body cam images dramatically. And that's because of software. Do changes send change deltas? So if you mean by change delta, that's exactly what we're looking at in the change stream. So all change events are change deltas. You have to compare it with what you have on your client. You also can allow the whole stream to be replayed if you get disconnected by including a flag, and it will represent all the documents as like initial changes of the things that are being created. So you can easily reset the state of your application as well in case of disconnection. Okay, Will Horizon eventually be available for iOS? So by default, Horizon will be a JavaScript API similar to something like Parse or Firebase that you can use and deploy. We're going to have a cloud service called Verizon Cloud. It's open source. You can deploy it where you want. You can scale it however you want. It'll be available on a cloud service that we're building called Verizon Cloud. And using a JavaScript API, it will be very simple to integrate with it. Particularly if you're building something like a React Native app, right, where you basically use the same code base for your desktop and mobile app. And then you can figure out how to get the data in the same consistent fashion. We will eventually probably build a really good integration with like native iOS libraries, just because that's really nice to use some of the native tools that they have available. How do you support an open source community? So if you're talking about what we do for our open source community, that is I want to make sure I understand the question correctly. So I'll answer how I think you're asking, which is what do we do for our community? So for one thing, we have a full-time community manager she's an amazing person who reaches out and is familiar with a lot of our users around the world. And some of the things that we do to interact with them is we help them run meetups. So we ship them like a box. It's like a meetup in a box. It comes with everything you need to start a meetup and a guide on how to do it. T-shirts, little plushes of the thinker, things like that to be able to get a group started. So we have groups that meet in places like Salt Lake City, in New York, in Berlin, in London, and there are groups all around the world that are popping up. And we try to see these communities and understand exactly what they need to be able to get into the next place. RethinkDB is open source, so it gets into places you would not expect. People smuggle it in. They just want to use it because it's the best tool for the job, which is what open source forces infrastructure companies to do. It forces them to think about building the best version possible of their software. Because if it's open source, you get massive distribution, but it has to be the best tool in its class. You can't get away with shipping a half-baked product because people just won't use it. They'll just use something else. Other things that we do for our community include we do shirts for stories, which allows people to tell us how they're using it and also gives us leads on what companies and teams are playing with Rethink. And they get free T-shirts and handwritten notes from the team. We have a full-time artist who will draw illustrations for the community from time to time. We also have a team of community folks who do things like create tutorials, guides, articles, and try to figure out what people need to be able to use RethinkDB more effectively. If there's any other questions, you're happy to drop them in. How do events work? So basically, as I mentioned, you just get a feed from the database, and you would manage the event with something like Socket.io to push it up to the front end, or whatever other system you like. In Ruby, there's Fay. In Python, there's equivalent systems. I can't remember the names right now. But Horizon makes all this a lot easier because you don't have to think about it. You just handle the event straight from the browser. You don't think about like a database or backend. How do we make money if everything's open source? Good question. So fundamentally, the first way we make money is through client services. Teams need help building and scaling real-time architectures. We provide an SLA so that when things go down, we're the ones on the line who can help figure out what's going on. And we also help with things like query performance. We do training. We do a lot of professional services. What we're really excited about is that we're taking the same client service knowledge that we've been building, because we know a lot about building real-time architectures, building real-time apps, scaling data layers. And we're sharing it via a cloud service that we're building, Horizon Cloud. So we're going to do the same thing we're doing right now, but we're going to help people scale these kinds of apps like for any user that needs help doing it. So they'll be able to, you can start building your Horizon app, and then you're going to be able to deploy it on our cloud where you can choose where you want it, like Amazon or Google or DigitalOcean. And then what we do is we manage all the ops. So there are still problems that come up, like how do you do multi-data centers, right? How do you do availability zones that roll over? How do you do backup? How do you do logging? How do you do rolling application upgrades, migration, development and production environments? So all these problems are still really hard on ops, and we help a lot of people solve those problems right now via client services and ultimately via software. How do you handle pagination performance? Really good question. What we do is you can index on properties, and then you can use a command called between to be able to get between certain ranges, and then you can limit the amount you get for each page. There's some really great examples on our blog of how to do pagination performance with real-time updates. It is definitely a problem worth solving that a lot of other systems have not solved, and that's because their architecture means the kind of queries you can run are simpler. So in Rethink, the kind of queries you can run are much more complex and rich, and so doing something like pagination efficiently is definitely possible. All right, next question. I'm going through these quickly, so I hope you're with me here. I know I speak really quickly. I appreciate it. If you have follow-up questions, just feel free to post them. Is the JavaScript driver isomorphic? So it depends on what you mean by isomorphic, because So the JavaScript driver is meant to be used on the back end for RethinkDB. It's not meant to be used from the browser, right? You're supposed to do all your front end work using some other tools because you don't want people to just have access to your database, right? You want like your data to be safe and have good access control. So what you want is the driver itself. It looks a lot like the queries I was writing before, where you write it in JavaScript and then the expression gets compiled down and sent off to the cluster, executed in distributed fashion and then sent back with the result. In Horizon, the API for Horizon is not just the query language in the browser. We were going to do that at first, and we realized it's too powerful. It's just a programming language that's in your browser, and that's too much. You can't do access control. You can't figure out how to reason about what data is where. So we built a simplified version of the API inspired by the same query language, and it feels and looks a lot like it. When you're ready to grow your app past Horizon, you can still work with the database. So you can start to actually add custom code using REQL. So you can use Horizon queries and REQL queries, but they're very different because their needs are very different. One, it's the browser, it's public, it's the world. The other is for like sophisticated database queries you can run. I'm going to just jump down here because this is a good question that someone popped up. Can you use GraphQL with Horizon? The answer is that was the original plan for why we built Horizon. So people wanted us to add GraphQL support. GraphQL is a really great technology if you're not familiar with it, that abstracts away data sources and allows you to like build higher level data models that let you basically write what you want for the app, and then the backend has to fulfill it somehow. It's neither a graph query language nor a query language, right? But it's a data format that basically is a replacement for REST that defines how you can get data from back and forth from the back end to the front end. And so we didn't want to put GraphQL into RethinkDB, so we started building Horizon as a way to get GraphQL as a method for getting data out. So by default, we have this simple API described. But we don't want to make any definitions about what you do in the browser. We don't want to make any definitions about how you get data in or out. We stop at the reactive data layer. So you can use GraphQL. We're going to add GraphQL support. That's definitely like one of the first features we planned. And Falcor and other systems that come out, other ideas for how to like get data in and out are going to be added to this like convenient distribution modules because we think these ideas are really important. Okay, let's keep going around. Is the dashboard open source also? Yes, but it's tightly integrated into RethinkDB. All of RethinkDB is open source. It's mainly C++. It goes all the way down to assembly because there's like some custom like assembly logic that's going on for some of the high performance stuff, and all the way up to the browser where you have the dashboard that's being implemented in your browser in JavaScript. Okay, Horizon and mobile apps. Absolutely. Horizon is designed to help you build mobile apps and desktop apps. React and React Native is an example of how we see app development moving forward. But if you just have an iOS app, it'll work with it as well. We already have demos working. And there are apps that have been shipped to the App Store that already use Horizon. How are indexing and performance addressed? This is a very complex topic, so I'm going to talk just briefly about it because there's a lot of details to get into. If you have follow-up questions, we can get into it. So indexing is, there are no indexes automatically created for you in RethinkDB because we prefer explicit indexes that you define and control by hand, so you're not surprised by your query. Because RethinkDB is so powerful, it really makes you think about how you're using your data, and running your indexes and managing them is not very complex. So all secondary indexes are supported across the board. You can do arbitrarily, you could use functions for your indexes as well and things like that. In terms of performance, the performance is very good. We're issuing a report soon that demonstrates doing 1 million reads per sec and writes per sec on a 16 node cluster, 1.3 million reads per sec on a 16 node cluster, and I can talk about an independent performance report that I mentioned. They got to 1 million on a 30 node cluster on Amazon. So performance is very good. It's at par with most other database systems and better in some cases, a little bit worse than some. We're working constantly on performance. Every time that there's a specific workload that doesn't work well, it's a bug, and we go and fix it. And ultimately, the performance has been dramatically increasing over time. So at this point, it's pretty fast. And a lot of teams are relying on it for their primary operations. Are there any hosting providers supporting RethinkDB? So there's Compose.io, which was recently acquired by IBM. Compose manages RethinkDB in the cloud for a long time. They're a very good provider. They also manage other databases like Redis, MongoDB, and other systems. You can run it on AWS as well. There's just an image you can run. There's a Docker image, so it's really easy to pull wherever you want. Very popular Docker image. Ultimately, when we'll be hosting Horizon, we'll also be managing some RethinkDB instances for people. But Compose.io is probably your easiest way to get up and running right now. What is the eventual consistency? Okay, so that's a really interesting question. RethinkDB, for those of you who are familiar with the semantics of distributed systems, RethinkDB is an immediately consistent system. So it favors consistency over availability. This is a fundamental trade-off of physics that occurs within distributed systems. What this means is, in some systems, like React or Cassandra, if a node goes down, then it doesn't matter. Things will just keep maintaining operations. And when they come back up, you have to resolve the differences, whatever might have changed in your application. This is really frustrating for developers. So because we're building not for things that need to stay up 99% of the time without fail, and if we lose 30% of the data, it doesn't matter. Like that's like analytics are like that, right? You don't really care if you lose 30% of analytics, so it doesn't matter, right? If you lose some of the data. We really care about losing the data. We don't want to do that. So we're immediately consistent. What that means is when you issue a write in RethinkDB, it is acknowledged by disk by default. You can turn that off so you can get it acknowledged like in memory, right? To be able to make it a little bit faster. But the idea is that it is immediately consistent. So whenever you do a write, like you don't have to worry about what the consistency is. Does anyone know of a good Redux plus RethinkDB integration? Yes. If you look at, I mentioned these stacks before, right? So if you look at the 3 stack, that's 3 as in the number, and then REE. I'm going to type it into the chat just so you guys have it. So the 3 stack is a really good post that people have. It's a really good stack and a really good blog post. And I come with some examples where they've integrated React, Redux, Express, and RethinkDB. So the 3 R's, React, Redux, and RethinkDB and Express. We also plan to figure out a good way to do Redux plus Horizon integration, because Redux is a really good way for managing application state. And it really meshes with the ideas that we have around unidirectional data flow, state of truth, and be able to build these kinds of real-time apps. It's like a very good way of thinking about the world. Okay, I'm going to take a moment to pause here because I've been talking for a while. Okay, apart from being self-hosted, how is this different from Firebase? Okay, so RethinkDB is not at all like Firebase, because Firebase is like a service, right? And it's a cloud service that like gives you a very limited API. You can really just get and set data and do some very limited things like limits or things like that. RethinkDB is a full-fledged database with distributed joins, with full queries, but it doesn't give you any APIs or convenience tools, right? So it's just a database. It's something that Firebase would use under the hood to build. So actually Firebase incidentally used MongoDB when they were building it. And because of this, that's why the feature set is somewhat limited in the kind of queries that you can run, right? So you can really only do certain things because MongoDB itself was not designed as like a massively parallelized distributed system, right? So RethinkDB is way more powerful, but doesn't give you the convenience or self-hosted aspect, or rather, or cloud service, right, or API. Horizon is a much better comparison point to Firebase. Horizon is similar to Firebase in that it makes it much simpler to build a front-end only app. And you can use the same APIs to be able to build all the things out. It feels a lot like Firebase on your laptop. Where it's different is that because RethinkDB is running under the hood, the kind of queries and the kind of things you can do with your data is just significantly richer than Firebase. Because the actual queries you can run are just richer. The whole database is doing all the work. The other thing is that the API can be extended. So because it's not just a cloud service, it's actually also a stack of node modules. When you're ready to write custom backend code, you can push past that. You can start writing backend code. You can't do that with Firebase. As developers, our tools limit our imagination. And so when you have an API that presents you with, here are the things you can do, but that's it. That's like the bounds of what you can build. And so Firebase is very difficult to use for larger apps because at some point your needs grow. You want to do more things. Horizon is designed so that you start with Horizon from the browser, you move to your backend, and then you can move to building scalable architectures as your needs grow. And so it really is more of a convenient way to work with building JavaScript apps that looks and feels like Firebase, but you don't have to give up any of the details. Horizon Cloud will be like Firebase is right now, except that we want you to start with the development experience first. We want you to just start building on your laptop, get the thing on your system, get it running, and then you can scale and build it up. Okay, so the question I have at the top here, by the way, if you have any more questions about any of this, please do follow us. In a nutshell, is this a VCS-based database? If you are saying version control system by VCS, because acronyms are always can mean a million different things. If you mean version control system, I would say no. It's not a version control system database. The reason why is that in a version control system, let's say Git, you can always roll back to wherever you want it to get to. You can pick the hash for whatever event you want, and you can roll back to whatever makes sense. In Rethink, the state of truth is always being updated. We don't keep the historical version of it. You could absolutely model that in Rethink. You could have like a table that is just a log of what has happened with like timestamps that allow you to attach like what the state of data was. So it's very easy to build a VCS-like thing in RethinkDB. But RethinkDB is fundamentally about pushing out streams on what exists in the database and what changed between like what has just happened. It's about the current moment of reality. If you want to build a VCS type system, it is absolutely possible with something called an event sourcing pattern. If you're familiar with event sourcing, if not, I'm going to just type it into the chat. I would recommend that you Google and read up on event sourcing patterns. Really, really good for building really complex applications. Yes, as in CQRS, that's correct. Okay. By the way, I just want to make sure that I'm answering all the questions here as well. Yeah, I can see someone figured out how to break my demo with a little JavaScript function. Nice job, Ian. Very proud. Okay. Okay, you cannot query by value in Redis. I actually am not familiar with Redis, so when I'm not certain what you're asking to accomplish in Rethink because I don't know how Redis works in terms of querying by values. However, in Rethink, you absolutely can query by values. It will be far more efficient if you index it for obvious reasons. But you can write queries that will examine any aspect of the system, any document. You can even modify the documents and do comparisons on them. The kind of REQL queries you can write are truly immense if you really want to put your mind to it. Okay, on indexing and performance. Yes, okay. So let's chat about indexing and performance for a minute. So basically, indexes are managed in a manual fashion where you define your indexes. The way you do that is in the UI. Like I can go here and we can look at our table, like questions. And here we have our questions table. And you can see that right here, if I wanted to like reshard and replicate it, I could like change the shards and replicas right here, and it would let me manage it right from the UI. But you can see I have a single secondary index created called points. So without this, when you run a query, some queries will not run if you don't use an index. So like you need to create an index before you can use this, because otherwise it's going to have to go over every element within the database, right? Because without an index, without some sort of reference of what's within the whole database, you're always going to have to do like a full table scan. This is how all databases work, because you don't know what's out there. You don't know what's in your system. So you want to create indexes, as many as you need to use. And these indexes, it looks like an order by, like this query that I ran before. I would say order by, and I mentioned the index, but I say let's use the points index. And then I can modify it. I can say take the values and points and flip them using r.descending. So these indexes are integrated into the query language in a very fundamental way. And basically when you run this operation, is that it's going to take the query that you run, it's going to push it out to the cluster, it's going to spread it out to the cluster in an efficient distributed fashion. Each node will get the query, this query that we have here. And then each core on the CPU will get the query for the bit of data it's responsible for. So it then moves out to all the cores. And then the core talks to the storage subsystem and figures out exactly the bit of data. It runs the computation on just that little chunk that it owns. And then it sends the result of the operation back up. That then bubbles up back to the node, then bubbles up back to the cluster. So you can see it's a sort of streaming parallel thing. So all the operations, not all of them actually, most of them are, but we're adding more every day, are massively parallelized because the architecture is capable of doing that. Because of this, performance tends to be either really, really good or really surprising in some unique workload that we haven't like touched. So for example, like someone who was doing some really crazy things with GeoJSON geometries. You can store like geometries in a database, right? You can query it by like, tell me if I'm like within 2 miles of this latitude and longitude, right? And so someone was doing some just insane number of geometries, because what they were doing was they were using laser scanners to like map the like plant growth and to figure out like what the geometry of it is growing. So they're doing just a ton of updates. And so in that case, they found that there was like some edge case like performance issue. And so we went and fixed it and released an update a week later, and then the performance issue was resolved. In general, performance is something that you have to test yourself, right? So there are a lot of factors that go into it. Whether you're batching your data, whether you're waiting for a response from disk, whether you're waiting for a response from memory, whether your operation is operating across your entire data set or just a subset of it. And so the answer is that you always have to model what you want from your performance. And we do a lot of that work with our clients. So there's a specific concern, you can chat with us on Slack, or we can figure out like an exact query plan for a query that's running for certain projects. I hope there's questions about queries and performance, or performance and indexing reasonably well. I don't know if there's any other questions that someone has. We have 1 minute left. I want to thank you all for the time to chat. I really appreciate your bearing with me through all these details. We covered a lot of ground. And if you guys have any follow-up questions, you can reach out to me at mike@rethinkdb.com is my direct email. You also can find me as mglukov at Slack. And I urge you to follow the project on github.com/rethinkdb. Go start the project. It helps with the visibility. And I know I speak super quickly, as someone mentioned in the chat. I appreciate your bearing with me, and I hope you guys all have an amazing day. I'm going to turn it over to Mike if he has anything else to say or any other comments. We'll close it out.
No, I think I speak about it with everybody. That was awesome. We really, really appreciate the time. I know that a bunch of people probably have some more follow-up questions for you. Probably want to start.
Mike, I think you may still be muted by chance, because I'm not hearing you right now.
Am I muted? Anybody hear me?
I can hear you.
Cool. Awesome. So I just wanted to say thanks for the time. I know everybody here is sort of jumping, but I just wanted to, share everybody else's enthusiasm, and we really appreciate the hour.
Yeah, I just want to jump on in and just say I certainly can think of a number of projects that we're working on that may make use of these kind of tools, and it sounds like from the questions that we got and some of the private chats that I got as well, is that people have indicated interest in this. So we're really curious to get a chance to play with us a little bit more, and I'm sure some of us will be reaching out with additional questions as well. So thanks for the time here. Thanks everybody for joining Clever Friday on a Wednesday. We will be recording this. We recorded this. We'll make it available to everybody who missed it, and Mike will of course send you a copy as well.
Cool. See you guys.
Thanks everybody.
See you. Bye.